Okay, lesson 8.5. The goal today is to find the area of parallelograms. Now, earlier this year we talked about parallelograms and we had a few properties that we remembered about them. Think about those properties for a second. What does a parallelogram look like? It tends to look like there's some parallelograms that will look like this. What other shapes are also parallelograms? Well, we have rectangles that are parallelograms. We have squares that are parallelograms. Okay? And so, and rhombuses are also under the category of parallelograms. So, the formula for a parallelogram is the area formula for a parallelogram is the base times the height. Okay, so base times height. Anytime you have a parallelogram, and again, thinking back to those four properties we know about, opposite sides are congruent and parallel. And parallel. Alright, that was the first property. We had a few properties about the angles. We had opposite angles are congruent. We had three that consecutive angles were supplementary. And last we had that the diagonals bisect. Okay, so that's how we identify a parallelogram based on those properties. So the area formula for a parallelogram is just like a rectangle's area formula. Okay, it's base times height. Now, the one thing that will be different about a parallelogram is that the height will not typically be on the outside. It will be in the inside of the parallelogram. But it always forms a right angle with the base, so this could be our base, and this would be the height. The area of a rhombus, however, is 1/2 the product of the diagonals. And product, we know, means to multiply. So we have 1/2 the product of the diagonals. Diagonals drawn in a rhombus. Each rhombus has all congruent sides. If we draw those diagonals, we would do the length of diagonal 1 times the length of diagonal 2, and just take half of that. So, for example 1, find the area of a parallelogram. We have the height, we have the base here, and so we can just plug those numbers into our formula. Base times height, which would be 48. And we're talking about yards, so don't forget square units, since we're talking about area. Alright, so take a moment, calculate the area of the parallelogram using the formula, base times height. Alright, so for number 1, the area would be base being 5. The height always forms a right angle with that base, so it's 945 square meters. Number 2, the base is 17. The height, notice how they label the height on the outside. It's still the same as if we were to label it on the inside as well. It still would be 12 centimeters. So don't let that throw you off, but remember the height is always that perpendicular distance from the base. So it should always form a right angle with the base. So area equals 17 times 12, which gives me 204, and the units would be square centimeters. Number 3, base times height, 14 times 14, and in this case, that would give me 196 square feet. Lastly, number 4, again, that height is on the outside, and that's okay. It's just that distance um, that perpendicular distance from the base. So this would be 10 still. 12 times 10, which would give me 120 square yards. Example 2 says find the base of the parallelogram. So just like we had in previous sets of notes, sometimes we may have the area and maybe one other measure, but we will need to find another length of the figure. So here we need to find the base. We have the height. We have the area. So we know the area is 105. The height is 7. So we divide by 7 on each side to get 15. So the base ends up being 15 inches. 5, 6, and 7 take this time to complete those and get the missing length. Alright, so for number 5, if the area of a parallelogram is base times height, we are going to substitute 63 in for A, the area. Base, we do not know. Height is 9. And we'll divide each side by 9 to get the base. And so for number 5, the answer would be 7. We're talking about meters in this case. Number 6. Area is 144 square foot. The base is 16. The height we do not know. To get this h by itself, we divide by 16 on each side. And so number 6, we get a height of 9 feet. And lastly, on number 7, the area is 55. The base, we do not know. The height is 5. I want to get this base by itself, so we divide by 5 on each side, and we get the base to be 11 when we simplify. 11 what? Centimeters. Alright, so the rhombus is a little bit different. If we're given the lengths of the diagonals of a rhombus, we can calculate the area. And that formula is 1/2 diagonal 1 times diagonal 2. So we need to get the length of the diagonal. This is one diagonal, and this is the other diagonal. So this entire diagonal 2 would be a length of 6, and this entire diagonal 1 would be a length of 12. Okay, so we're using those values right here, 12 and 6. So 1/2, 12 times 6 will give me the area of the rhombus. 1/2 diagonal 1 times diagonal 2, and we get 36 square feet when we simplify. So looking at 8, 9, and 10, take a moment and try to complete that using the area formula of a rhombus. 1/2 diagonal 1 times diagonal 2. Alright, so for number 8, even though the diagonals are not drawn inside the rhombus, we know the lengths of them because they give us the entire length across here is 14. The entire height here would be 8. So those are our diagonal lengths. So we would say area equals 1/2 diagonal 1. Well, it can be either one of them. And diagonal 2. And then we need to simplify. So we get 1/2 of 14, which is 7. 7 times 8, which will give me 56. And the units would be square meters. Number 9. They do not give us the entire length, but they give us parts of the diagonal. So this is diagonal 1, 5 plus 5. That gives me 10 inches. 7 plus 7 gives me 14 inches, so those are my two diagonal lengths. So the area would be 1/2 10 times 14 here. And that gives me an area of 70 square inches when I simplify. Number 10, they give me one of the inside diagonals going horizontal, and the vertical one is also 12, so that gives me an area of 1/2, 12 times 12. And so we get that final value to be 72 square